Hello, in this lecture we are going to start with real sequences and their convergence. Okay, and this is an important topic for your exam also and otherwise also. And we'll real sequences and their convergence. Real sequence and their convergence. Okay, so why directly jumping to the topic? Because I felt that instead of going here and there, let us first start from the topic which is directly coming in the examination. All the other small topics I'm going to cover in small sections, but let us first understand what is a sequence. Okay, so let X be a non-empty set. Let X be a non-empty set. What is a sequence? See, how do you associate yourself with sequence? Let's say I am saying that I have a sequence 1, 2, 3, 4, so on and so forth. Or I say my sequence is 2, 4, 6, 8, so on and so forth. Or I say that my sequence is 2, 4, 8, 16, so on and so forth. So in all of these kind of sequences, you can associate a function from n to any like here these are all real numbers, but in general if I make a function, if I declare a function from a natural number to a set x, then I say that I'm defining a sequence in x. In particular, in our syllabus, x would be equals to r. So a sequence in x is a function defined from n to x. Okay, so function which is defined from set of natural numbers to a set x is said to be a sequence in x. In particular, if x is equal to r, then we say that we are discussing real sequences. Okay, our prime our prime focus is on seeing which of the sequences converge and which do not. Okay, so this is our prime objective of studying sequences. That what all sequences converge and what all sequences don't converge. Let us take a few examples and then let us jump directly to the things. So for example, one of the sequences, an easy example, is a constant sequence. What do I mean by constant sequence? That for each, let's say if this is how I describe my sequence. So most often you'll find this way or this way. Okay, so most often in books you'll find this kind of notation or this kind of notation. Okay, let us say I'm discussing constant sequence. What does it imply? If I want to find the first term, this will be C. If I want to find the second term, this will again be C. If I want to find third point, it will be C, so on and so forth. So all the terms in the sequence will be constant C. For example, I am discussing one of the favorite examples of yours, that is 1 upon n. So 1, 1 by 2, 1 by 3, 1 by 4, 1 by 5, dash, dash, dash. Okay, so this is yet another sequence. What can be another sequence? Let us say another sequence is xn is equal to minus 1 raised to power of n plus 1 upon n. Good part about this, the different part about this is now this will contain both positive as well as negative terms. I hope all these things you are getting. Let us say we are discussing another sequence, xn is equal to minus 1 raised to power n. It will be alternatively minus 1 plus 1 minus 1 plus 1, so on and so forth. Okay, so all these are sequences. Okay, when do we say that our sequence is convergent? A sequence is said to be convergent if the limit xn exists uniquely. So I'm going to write it. a sequence xn is said to be convergent if the limit of the sequence xn exists uniquely. Exists uniquely. By which I mean that limit n tends to infinity, xn must be some unique limit, let us say L. If this is the case, then I will say that my sequence is convergent. Now in epsilon and delta terminology, let us come and understand all those things. So if I say that what do I mean when I say that my sequence is convergent, let us try to find an answer using epsilon del approach. So if my sequence xn is convergent towards x, what does it mean? If I'm saying that the terms of the sequence are converging towards x, it implies that after a certain n, most of the terms are close to x. In Hindi I'm saying अगर xn और x की दूरी कम की जा सके, कम क्यों की जा सके? अगर मैं कह रहा हूं कि xn कन्वर्जेंट है और x पे जाके कन्वर्ज करता है, इसका मतलब क्या हुआ? इसका मतलब ये हुआ कि आपके जो एलिमेंट्स हैं xn के, वो एक n के बाद कहीं ना कहीं x के करीब पहुंच जाएंगे मतलब x after a while, after some natural number, the distance between xn and x can be made as small as possible. देखो पहली चीज समझने की कोशिश करो, कन्वर्जेंस का मतलब क्या होता है? कन्वर्जेंस का मतलब तुम कहीं अप्रोच कर रहे हो, राइट? इफ आई एम सेइंग xn is approaching x, इसको कैसे लिखोगे मैथमेटिक्स में? अप्रोचिंग जैसा कोई शब्द थोड़ी होता है मैथमेटिक्स में। तो अप्रोचिंग का मतलब क्या हुआ? जैसे कि हम मान लेते हैं कि इस तरीके से कुछ दे रखा हमारा, ये तुम्हारा n मान लो एंड ये तुम्हारा xn मान लो. Consider this to be n, consider this to be xn. Now what is happening? Let's say x1 is this, let's say x2 is this, let's say x3 is this, let's say x4 is this, let's say x5 is this. Okay, okay, and let's say x6 is this, let's say x7 is this. Now after some natural number you find that all the points are coming somewhere very close, so you will say that after certain natural number the points are getting accumulated in some width. Okay, you are able to find that these points are getting accumulated within a width. Okay, so what do I mean, what do I want to say? दूसरा तरीका क्या हो सकता है कहने का? अगर मैं कह रहा हूं xn x को अप्रोच कर रहा है, इसका मतलब क्या हुआ कि बहुत सारे एलिमेंट्स जो xn के हैं अब वो x के करीब जा रहे हैं. करीब जाने का मतलब क्या होता है? ऐसा कोई इनफॉर्मल सेंस तो बनता ही नहीं कोई चीज कहने का. तो इसको फॉर्मली कैसे लिखते हैं? डिस्टेंस कैसे बताई जाती है? मॉडुलस से. सो xn माइनस x का मॉड कैन बी मेड लेस देन एप्सिलॉन. अब एप्सिलॉन क्या है? एप्सिलॉन तुम्हारी टॉलरेंस लिमिट है, तुम्हारी एक टॉलरेंस लिमिट है. तुम कह रहे हो कि ठीक है, मैं समझाता इस बात को, मैं समझाता हूं 2 मिनट को. ये तुम्हारी टॉलरेंस लिमिट है. जैसे कि अमित अभी लेक्चर अटेंड कर रहा है, अभी मैं कहता हूं कि लिमिट 1/n क्या होगा, तो अमित मुझे फटाक से कहेगा 0. Okay, Amit will say that limit 1/n equals to 0, isn't it? By intuition he knows that limit 1/n is 0. Now what does it imply? Now I will ask him ki how do you say this 0? So he would say that 1/n and 0 distance can be made as small as possible. So what Amit would instantly say? He would instantly say the distance between 1/n and 0 can be made as small as possible. Okay, this is what he is going to say. Now ये as small as possible जैसा सेंटेंस का कोई मतलब बनता नहीं, तो आप क्या कहोगे? कितना करीब? You will ask Amit, let's say आई एम सुदीप एंड अमित इज देयर. नाउ आई एम आस्किंग अमित कितना करीब. तो अमित कहेगा अच्छा ठीक है, मैं ऐसा कहूंगा सॉरी अमित को कि चलो ठीक है, तुम मुझे ये बता सकते हो क्या कि 1/n और 0 का डिस्टेंस 10 की पावर -15 से छोटा हो सकता है. मेरे लिए काफी छोटा नंबर है. मैं कहूंगा हाँ ठीक है, 1/n अब 0 के बहुत करीब है. कब? जब 1/n और 0 का डिस्टेंस मैं 10 की पावर -15 से छोटा बता पा रहा हूँ. तो अमित मुझसे इंस्टेंटली कहेगा अच्छा ठीक है, यस मैं बता सकता हूँ. कैसे? नाउ ही वुड से 1/n -0 का लेस देन 10 की पावर -15 और n should be greater than 10 की पावर 15. तो what Amit would say to me, okay, कि you want, मतलब वो मुझे कहेगा you want कि 1/n और 0 की डिस्टेंस 10 की पावर -15 से छोटी हो जाए. मैं कहूंगा हाँ I want that. तो अमित कहेगा okay, take any natural number which is greater than equal to 10 की पावर 15 plus 1. So if I take any natural number which is greater than 10 की पावर 15 plus 1, then 1/n will be less than 10 की पावर -15, obviously. So what will happen? So I gave Amit an epsilon. मैंने अमित को एक एप्सिलॉन दिया था कि मैं ये मान लूंगा तुम्हारी बात कि 1/n 0 की तरफ कन्वर्ज कर रहा है. कब? जब 1/n और 0 का डिस्टेंस तुम किसी नंबर से छोटा बता पाओ. मैंने कहा अच्छा ठीक है, 1/n और 0 के बीच का डिस्टेंस मैं 10 की पावर -15 से छोटा बता पा रहा हूँ. बता पाऊंगा क्या? तो अमित ने कहा हाँ बता पाओगे, प्रोवाइडेड आप एक नेचुरल नंबर ले लो 10 की पावर 15 प्लस 1 से बड़ा. इससे पहले कहीं पर भी सीक्वेंस के एलिमेंट, उससे फर्क नहीं पड़ रहा. लेकिन एक नेचुरल नंबर के बाद सीक्वेंस के एलिमेंट किसके बीच में आ जाएंगे? इस विड्थ के अंदर आ जाएंगे. दिस विड्थ इज सिंपली 0 माइनस एप्सिलॉन. इसको एक काम करो, इसको 0 मान लेते हैं यहाँ पर, ऐसे इसको हटा देते हैं. ठीक है, और ये हो जाएगा 0 प्लस एप्सिलॉन. Okay, now all the elements of the sequence after n greater than 10 की power 15 plus 1 are lying in this particular width. So I will say that my sequence is convergent. और ऐसा कब होगा? For every given epsilon. ऐसा जरूरी नहीं है, ये तो मैंने कहा था. Let's say कोई और आता है, let's say कोई और आता है और कहता है कि अच्छा ठीक है, क्या आप 10 की पावर -18 से छोटा कर सकते हैं डिफरेंस? तो मैं कहूंगा हाँ अमित कहेगा हाँ कर सकते हैं, प्रोवाइडेड n आप ले लो ग्रेटर देन 10 की पावर 18 plus 1. So for every given epsilon, if I am able to produce an n naught such that xn minus l का mod is less than, for every given epsilon, so for every given epsilon greater than 0, xn minus l, if it is can be made less than epsilon for all n greater than equals to n naught, this implies that my limit xn is equal to what? L. Is that clear, Amit, or is that not clear? I hope it is clear. सो इसको कहते हैं लिमिट का कंसेप्चुलाइजेशन. मतलब मेरे कहने का मतलब ये है, वापस समझने की कोशिश करो, ये बहुत प्राइम इंपॉर्टेंट कंसेप्ट है और इसी को लगाना आना चाहिए अब तुमको बार बार. ठीक है, सो इफ आई एम सेइंग दैट माय लिमिट xn एग्जिस्ट, इफ आई एम सेइंग दैट माय लिमिट xn इज एग्जिस्टिंग, देन आई मीन दैट xn इज कन्वर्जेंट. पहली चीज. दूसरी चीज मैं क्या बोल रहा हूं साथ ही साथ, आई एम सेइंग दैट if limit xn exists, it implies what? Let's say limit xn is equal to L. What does it imply? That sequence के elements L की तरफ जा रहे हैं. तरफ जाने का मतलब नहीं समझ में आता मैथ्स में. ठीक है, मैथ्स में you need to be formal. So what is the formal statement? Distance between xn and L can be made as small as possible. How to quantify that statement as small as possible? Let us say it is less than epsilon. For any given epsilon, if I am able to produce an n naught such that xn minus L का mod can be made less than epsilon for all n greater than equal to n naught, this implies that limit xn is equals to L. And if this particular limit exists uniquely, then I say that my sequence xn is convergent. This is point number 1 that you should be remembering. Okay, this is the point number 1 that you should be remembering. Is that clear? I hope it is clear. Please let me know. किसी को नहीं समझ में आ रहा तो please let me know. Okay. Second thing one must remember is the uniqueness of limit. The second thing that you should remember is the uniqueness of limit. So if I am saying that sequence is convergent, then the limit must be unique. So if my sequence xn is convergent, then limit must be unique. What does it imply? That is, if my sequence xn is such that it converges to x and xn also converges to y, then sequence xn is convergent only if x equals to y. How come? देखो, if I am saying that xn is converging towards x, what does it imply? Xn minus x का difference can be made less than epsilon. Let's say I'm saying, let's say epsilon. ठीक है? Let's say epsilon. When for all n greater than equals to n1. What does it imply? Second statement, xn converges to y means what? Xn and y, the difference of xn and y can be made less than epsilon for all n greater than equals to n2. Now, if I select some n0 which is maximum of n1 comma n2, what will happen? In this particular scenario, your xn minus x will also be converging. So if I select n0 to be maximum of n1 and n2, what will happen? Just think about it. So for example, now here I am just claiming one more thing. So another thing that I want to see is modulus of x minus y. So instead of writing modulus of x minus y, let me write xn minus x. और एक काम करते हैं, इसको epsilon by 2 कर देते हैं और इसको epsilon by 2 कर देते हैं. So if I am giving you an epsilon, if I am saying that my sequence is convergent, then for a given epsilon, I must be able to give you an n1. ये चीज समझ में आ रही कि नहीं आ रही? आप ये कह रहे हो कि आपकी xn जो है वो कहाँ कन्वर्ज कर रही है? x पे. इसका मतलब क्या हुआ? xn और x की दूरी कम की जा सकती है, जितना छोटा चाहे उतना छोटा किया जा सकता है. तो एप्सिलॉन से छोटा किया जा सकता है, तो एप्सिलॉन बाय 2 से भी छोटा किया जा सकता है. तुम कहोगे कि एप्सिलॉन बाय 2 से छोटा किया जा सकता है, मैं कहूंगा हाँ किया जा सकता है किसी एक n1 के बाद. ये कब कह पा रहा हूँ? ये मैं तब कह पा रहा हूँ जब xn कन्वर्जेंट है x पे. If I am saying that xn converges to x, then what does it imply? The distance between xn and x can be made as small as possible after some n1. Okay, now I am taking this distance x minus y. So if I want to take this distance x minus y, I can do it in this manner: x minus xn plus xn minus of y. This is also how I can write. Now by modulus inequality, I know this will be less than equal to x minus xn plus xn minus y. Now for all n greater than equal to n0, what will happen? For all n greater than equal to n0, even this will be less than epsilon by 2 and even this will be less than epsilon by 2. So what does it imply? For all n greater than equal to n0, mod of x minus y can be made less than epsilon. And if difference of two numbers can be made as small as possible, what does it imply? It implies that x should be equal to what? Y. Is that clear, Amit, or is that not clear? Please let me know. We are coming to the questions, don't worry. Okay. Okay. We'll come to the questions, don't worry. Okay. Good enough. Now, chalo. If I know all these things, a few more things I'm going to just write, because students take much. Okay, so let another thing, important point that I'm going to write, let xn be a sequence of real numbers let xn be a sequence of real number, and if xn converges to x, then modulus of xn also converges to modulus of x. Okay, but converse is not true. But converse is not true. Why? See, uh, if xn converges to x, what does it imply? If xn converges to x, it implies xn minus x can be made less than epsilon for all n greater than equals to some natural number, let's say n naught. Okay, now we have to estimate what? We have to estimate this. So let us estimate the distance of xn mod and mod x. So if I want to estimate this distance from the triangle inequality, I know that I know the modulus of A minus modulus of B is always less than equal to mod of A minus B. So this will be less than equal to mod of xn minus x, and for all n greater than equals to n naught belongs to natural number, I know that my xn minus x ka mod can be made less than epsilon, because I know that the limit of this sequence xn is x. So if I'm saying that the limit of xn is x, it implies what? It implies the distance between xn and x can be made less than epsilon for all n greater than equals to n naught. Now you see, if this is the case, then what is happening? Then I can also write that modulus of xn minus modulus of x can be made less than xn minus x, and this can be made less than epsilon for all n greater than equal to n naught. What does it imply? It implies modulus of xn minus modulus of x can be made less than epsilon for all n greater than equal to n naught. It implies that limit modulus of xn is equal to modulus of x. So given that xn converges to x, then always remember modulus of xn always converges towards modulus of x. Now, if this is the case, why I am saying converse not true? Take example of xn is equals to minus 1 raised to power n. So its modulus xn is equals to 1, which is convergent. However, minus 1 raised to power n is not convergent. Minus 1 raised to power n is not convergent. Minus 1 raised to power n is not convergent. Okay, why this is the case? Why do you think that xn is equal to minus 1 raised to power n is not convergent? Okay, why do you think that xn is equal to minus 1 raised to power n is not convergent? One that you can think is that the limit is not unique. The limit is not unique. But let us say we have to prove it, because I told you on the very first day. I jumped here because I thought students would not like it. Students don't like much of the basic things, so they actually want to jump directly to the proof, so directly to the question. So let us prove once that by minus 1 raised to power n is divergent. Prove that it is divergent. Why it is divergent? Let us say that my sequence xn is equal to minus 1 raised to power n is convergent. Let us assume the contrary. If this is the case, then xn minus x ka mod can be made less than epsilon for all n greater than equal to some n not belongs to natural number, and let epsilon be less than 1, because see, epsilon is any arbitrary positive real number. So if I am saying that xn and x ka distance can be made less than epsilon, why not let it be that xn minus x ka distance be less than 1? If I am saying that sequence xn is convergent and it is converging towards x, so it should be in the way that I can make this difference, that is xn minus x, as small as possible. So why not say that distance, let's say distance be made less than epsilon, where epsilon lies between 0 and 1. So what does it imply? It implies that xn would lie between x minus epsilon to x plus epsilon for all n greater than equals to n naught belongs to natural number. Now in particular, in this particular distance only, you will find x2n also lying, and in this particular distance only you will find x2n plus 1 also lying. You see, and let's say 2n naught or 2n naught plus 1, because this, I'm saying that all the elements of the sequence xn will lie between x minus epsilon to x plus epsilon for all n greater than equals to n naught. So just think about it, that in this particular width only, that in this particular interval only, x2 n naught will also lie, and x2 n naught plus 1 also would lie. See, n is greater than equal to n naught. So x2 n naught is obviously greater than equal to n naught, right? So x2 n naught will also lie, and x2 n naught plus 1 also would lie. What is x2 n naught? X2 n naught will be minus 1 raised to power 2 n naught, which is simply 1. And what is x2 n naught plus 1? This would be simply minus 1. So if both of them lie inside this, then the width of this interval should be at least 2. Because if both of them are lying inside, then the width should be at least 2. Isn't it? So what is the width of this particular thing? So your 2 epsilon must be at least greater than what? Greater than equal to, or you can say at least this particular width. I should write that this particular width should be at least greater than equal to 2. What does it imply? Your epsilon should be greater than equal to 1. And what did we assume? Epsilon should be less than 1. So here I arrive at a contradiction. What was the assertion? The assertion was, if I am saying that minus 1 raised to power n is convergent, then xn, and let's say if it is converging to x, then xn minus x ka difference can be made less than epsilon for any arbitrary positive epsilon. For every arbitrary positive epsilon. Whenever I say that sequence is convergent, then the distance between the sequence and its limit can be made less than epsilon for any arbitrary positive real number. For any arbitrary positive real number, the distance, what I want to say is, the distance between xn and x can be made less than any arbitrary positive real number. Why not less than 1? And if it is the case, then we arrive at a contradiction. It implies minus 1 raised to power n is not convergent. Rather, it is divergent sequence. Okay, rather it is divergent sequence. Okay, or otherwise, Amit also writes right answer. He says that repeatedly the limits are going to be minus and plus 1. Yes, the limits are going to oscillate, and if they are oscillating, it implies that they are not unique limits. Okay, now let us do a few questions to understand. You know about sequences, limits, and everything. So now let us try to do a few questions. Let us do a few questions, and then we'll see how many of you know how to find limits. Okay. So now let us find some limits to some sequences. Okay. First question that I'm going to give you is very simple. Just give me a simple. Just let me know whether you understand it or not. So I'm giving you a sequence. Let us define a sequence xn is equal to a raised to power n, b raised to power n, c raised to power n, whole raised to power 1 upon n for all n belongs to natural. Now tell me whether the sequence xn is convergent or not. Here a is positive, b is positive, and c is also positive. Is the sequence xn convergent? So is the sequence xn is convergent? What should I do? So yes, indeed the sequence is convergent. So I'll say xn is convergent. How come? See, these are all positive real numbers, and also you write distinct positive real numbers. Okay, so let me write these are distinct positive real numbers. These are all distinct positive real numbers. Now from law of trichotomy, you know that whether a would be greater than b, greater than c, or a would be greater than c, like there would be some order relation, right? There would be some order relation. If there are three distinct positive real numbers, one has to be greater than another. So let me define a maximum So let me define maximum of a comma b comma c as alpha. Now if a is maximum, alpha would become 1. If b is maximum, then alpha would become b. And if c is maximum, then alpha would become c. So if I'm saying that my uh, this is my sequence, I'm defining some alpha. This alpha is nothing but it is maximum of a comma b comma c. So if a is maximum, then alpha would become a. If b is maximum, then alpha would become b. And if c is maximum, then alpha would become c. So now just think over it, that if I take the maximum of this common out, let us say a is maximum. Let us say a is maximum. A is maximum means what? A would be greater than b and a would be greater than c. Now take a common out. So you'll get a outside. Inside you will get 1 upon b by a raised to power n plus c by a raised to power n, and this is whole raised to power 1 upon n. Always remember, limit n tends to infinity, a ki power n is equals to 0 if a lies between 0 and 1. It is equals to infinite if a is greater than 1. Always remember this. Always. That what I am saying, that if I am saying limit n tends to infinity, an, what it is equal to 0 if a lies between 0 and 1, and it is equal to infinity if a is greater than 1. So if a is greater than 1, the limit n tends to infinity, an would be, if a is greater than 1, limit n tends to infinity, an would be infinity, and if a lies between 0 and 1, then limit n tends to infinity, an would be 0. Now you see a is greater than b implies what? B by a would be less than 1, and also c by a would be less than 1. Both are less than 1 and greater than 0. It implies what? It implies b by a raised to power n would tend towards 0, and c by a raised to power n would also tend towards 0. It implies what? It implies that the limit of xn would be equals to what? Limit xn in this particular case would be equals to a. So if a is the maximum, then limit would be a. If b is the maximum, take b common out, and if c is the maximum, then take c common out. So what does it imply? It implies that my xn is convergent, and it converges to what? Xn converges to alpha, where alpha is nothing but it is equal to maximum of a comma b comma c. I hope अमित को समझ में आया होगा. Is that clear, Amit? Is that clear or not? Ria has joined. I don't know. She was in physics, I guess. Okay, but are you getting my point till now? I don't know. Somebody is getting the point or not. Okay, now let us do a few more questions and then we'll conclude this lecture. The second question is this one. What can you say about this particular sequence? What can you say about this particular sequence? So let bn be greater than equal to 0 and bn converges to 0. Let bn be greater than equal to 0 and bn converges to 0. Assume that there exists an integer n such that an minus a mod can be made less than equal to bn for all n greater than equals to capital N. Then option number 1, an would be divergent. Option number 2, an would be convergent and it converges to 0. Option number C, an would be convergent and it converges towards A. And D, an is an oscillating sequence. Is an oscillating sequence. Which of the following do you think is correct? Okay, so Ria says so much. Thank you so much, Ria, for supporting. Okay, so okay, right now I'm teaching all alone. Fine. So what do you think? What do you think that how would sequence behave in this manner? Okay, so I know. Uh, what should I say? I mean, here it is. So see, if Bn converges to 0, what does it imply? It implies the distance between Bn and 0 can be made less than epsilon for all n greater than equals to n naught belongs to natural number. This is what I can say. And since Bn is greater than equal to 0, whether you write Bn mod or whether you write Bn, it is one and the same thing. So instead of writing Bn ka mod, I can say that Bn can be made less than epsilon for all n greater than equal to n naught belongs to natural. So what does it imply? It implies that an minus a ka mod can be made less than epsilon for all n greater than equals to n naught belongs to natural. It implies that limit n tends to infinity, an is equals to what? It is equals to a. So please remember, if this is the condition supplied to you that an minus a mod is less than equal to bn, and bn is a convergence sequence converging towards 0, then limit an, here in this way it is defined, that is an minus a, it is defined. So an minus a mod is less than equal to bn, it is given, and if bn is converging towards 0, then an converges towards a. Why? Again understand, see, bn is tending towards 0. What does it imply? It implies bn minus 0 ka distance can be made less than epsilon for all n greater than equals to n naught. If this is the case, then bn ka mod can be made less than epsilon, and since bn is positive, so whether you write bn ka mod or bn, one and the same thing. So bn can be made less than epsilon for all n greater than equals to n naught belongs to natural. What does it imply? It implies in the very same line, by this inequality I can say that an minus a ka mod, since it is less than equal to bn and bn can be made less than epsilon for all n greater than equal to n naught belongs to natural number. What does it imply? It implies that limit an is equals to a. I hope it is clear. If you are not able to follow, please do let me know, because see, anyway, for a few days you need to keep patience. Once you keep patience, I can assure you that things are going to come soon. You're soon going to follow the things, but initially you need to be certainly patient enough. Okay, so that is something that I can assure, that once you are through. uh, Shashi says good evening. Yes, good evening. So I hope this is clear. Okay, good enough. So this is one thing. Now you see, another thing that I wanted to tell you, that what do you think about this? Always remember, one of the most important things that you should understand is that this is an important statement that I want to write here, and probably I'm going to prove it as well. So let xn be a sequence of real numbers. Let xn be a sequence of real numbers, and let us say that this xn converges towards x. Let us say that this xn converges towards x and this x is positive. That is, the limit of xn is positive. Then there exists some natural number n such that xk is always greater than x by 2 for all k greater than equals to n. What does it imply? It implies that after a natural number n, all the elements of the sequence will be greater than the half of the limit. Also understand that since x is positive, so it implies that the tail of the sequence would be positive. What does it imply? It implies there would exist a tail which would be positive. Okay, is that clear? I hope somebody is listening to the lecture. If somebody is listening to the lecture, please uh, keep making some conversation. Otherwise, it gets terribly boring. Okay, so I think Ria was there. Okay, Shashi is there. Shashi, is that clear? I mean, statement is clear. Statement says that let xn be a sequence of real numbers, and if xn converges towards x, where x is a positive real number, then there would exist some natural number n such that xk would be greater than x by 2 for all k greater than equals to n. What does it imply? It implies that after a natural number n, elements of the sequence would be greater than x by 2. That is half of the limit stated. Also understand, since x is given to be positive, it also implies that there would exist a natural number beyond which your elements of the sequence would be positive only. I hope this is clear to you. If not, let me know. This is the statement. Okay, this is the statement. See, how to go about this? So, let us say, let us apply the definition. So what does the definition say? So let us try to prove it. So how am I going to write the proof for it? I know that my sequence xn is convergent. If my sequence xn is convergent, then xn minus x can be made less than epsilon for all n greater than equal to some natural number n naught. Here epsilon is any arbitrary positive real number. Here epsilon is any arbitrary positive real number. Okay, now if it is any arbitrary positive real number, for any arbitrary positive real number, I must be in a position to give an n naught. If I am in a position to give you an n naught for any of your given epsilon. So I started my lecture with this particular example. I told that time Amit was here. So I told him, what is limit n tends to infinity? 1 upon n. He said 0. And I'm saying, why it is 0? Because distance between 1 upon n and 0 can be made less than epsilon. Now you just give me an epsilon. So he gave me an epsilon 10 to the power minus 15. So I told him, yes, I can make this distance 1 upon n and 0 less than 10 to the power minus epsilon, 10 to the power minus 15, provided I take n greater than equals to 10 to the power 15 plus 1. So if I take this, then I'm able to justify that 1 upon n and 0's distance can be made as small as possible. Now, as small as possible is not a very formal term. So how to quantify that particular term? Give me some epsilon. So you just give me epsilon, let's say 10 to the power minus 15. So I'll give you an n naught. In general, if you really want to inquire what would be epsilon in general, so epsilon in general would be this. Now what would be n naught? What would be n naught? N naught would be, just take n greater than equals to greatest integer of 1 upon epsilon plus 1. Just do that. This is your n naught. For every time you just give me an epsilon, I'll give you an n naught. You just give me an epsilon, I'll give you an n naught. What does it imply? It implies that you are in a limiting process. By limiting process, what do I mean? I can say that 1 upon n can be made as close as possible to 0 after a while, after a natural number. So this is how you define your limiting definitions. This is how you define your limiting behavior. This is how you define your limiting behavior. Now here, let us come back to the point. So if xn converges to x, what does it imply? If xn converges to x, it implies that distance between xn and x can be made as small as possible. So let us say I can make it less than epsilon. Now, since epsilon is any positive real number, why not epsilon can be x by 2? That is also a positive real number. So the inquiry, let's say whosoever is attending the lecture, let's say if I go by the name, Shashi is attending the lecture. So Shashi says, okay, if I am saying that xn is convergent, then xn minus x ka distance can also be made less than x by 2 for all n greater than equal to capital N probably. Now what does it imply? It implies that xn would lie between x by 2 to 3x by 2 for all n greater than equals to n belongs to natural. What does it imply? It implies xk will be greater than x by 2 for all k greater than equals to n, or in other words, xn would be greater than 0 for all n greater than equals to capital N. So the tail of sequence would be positive. I hope it is clear. If somebody is listening to the lecture, please let me know. Otherwise, I'll proceed. I don't know, somebody is not there. Okay, no issues. So I hope this is clear. So if I want to generalize this statement, the general statement to this would be, the general statement to this particular thing would be, a generalized version to this particular statement would be that let xn be a real sequence. Let xn be a real sequence such that xn converges to x. Assume that x is non-zero. If x is non-zero, then there exists some n belongs to natural number such that for all k greater than equal to capital, for all n greater than equal, since epsilon is any arbitrary positive real number, then why not take epsilon equals to modulus of x by 2? Let us define epsilon is equal to modulus of x by 2. Okay, sorry for the interruption, just give me a minute. Okay, sorry. Okay, so one thing is clear. I hope, just give me a minute. Okay. Okay, so let us estimate modulus of x. What would be modulus of x? So modulus of x would be simply xn, or I can say x minus xn instead, x minus xn plus xn mod. And if I want to write, I can also write it equals to x minus xn ka mod plus modulus of xn. Now you just think that if my sequence xn is convergent, then xn minus x ka mod can be made less than modulus of x by 2 for all n greater than equal to some natural number capital N. So what does it imply? It implies that modulus of x, which can be written less than equal to x minus xn, or shall I write xn minus x, one and the same thing. This would be it. And for all n greater than equal to capital N, this can be written, this particular thing can be written less than modulus of x by 2 plus modulus of xn, and in other words I can say that for all n greater than equal to capital N, xn mod can be written greater than modulus of x by. I hope it is clear. This is a more generalized version of whatever I was saying above. So always remember, if xn converges to x and if x is positive, then there would exist some natural number beyond which xn would be greater than x by 2, or in other words the tail of sequence would be positive. Precisely here in this particular case, the more generalized way of saying it would be this. I hope it is clear. If somebody is watching, please let me know yes or no, otherwise I will move forward. And it's not watching. Okay, another statement, I hope everybody has learned all these things, so I'm not going to derive it, is precisely very important, and it says that every convergence sequence of real numbers is bounded. Every convergence sequence of real numbers is bounded. Every convergence sequence of real numbers is bounded. Always remember. Okay, so always remember that every convergence sequence of real numbers is bounded. Converse, not true. Why converse is not true? Since see, if I am talking of bounded sequence, don't you think that xn is equals to minus 1 raised to power n is also a bounded sequence? However, it is a bounded sequence, but it is not convergent. This we have proved today itself. And how do you do this? Just a little greater than equals to n naught belongs to natural, right? So if I'm saying that my sequence xn is convergent, then xn minus x can be made less than epsilon for all n greater than equal to n naught. Let us say that let's say epsilon equal to 1. So xn minus x can also be made less than 1 for some n greater than equal to, let's say, let me change number and let me write it as capital N. Let us say this is the number. What does it imply? It implies that xn can be made, and now let us estimate. What we should estimate? See, we want to prove that sequence xn is convergent and sequence is bounded. So let us estimate what? Let us estimate modulus of xn. Let us estimate modulus of xn. So modulus of xn would be what? Modulus of xn would be simply xn minus of x plus x, and it can be written less than xn minus x ka mod plus modulus of x. Don't forget, what is xn? What is x? X is the limit of xn. Okay, so it implies xn ka mod can be made less than 1 plus, because xn minus x ka mod can be made less than epsilon, and what is epsilon? Epsilon is 1. This is how it is. Where for all n greater than equal to capital N. What does it imply? Let me write down the sequence elements. So it implies that sequence element xn, sequence element xn plus 1, sequence element xn plus 2, so on and so forth. For all these elements, this is very much clear that the upper bound would be 1 plus modulus of x. For all these we don't know. So what I will do, I will devise a strategy of writing some constant c as maximum. Let me write maximum. Let me find maximum of modulus of x1, modulus of x2, dash modulus of xn minus 1. I don't know what is. These are all finite numbers, so there would be some maximum. Let me write whosoever be the maximum between this and between this. Let me declare it is equals to c. If the maximum is coming beyond xn, that is x subscript capital N, then it will be less than 1 plus modulus of x. So the upper bound would be this. Here I don't know. Here I don't know what is maximum. So I'm just writing a c which is equal to maximum modulus of x1, modulus of x2, modulus of xn minus 1 and 1 plus modulus x, modulus of x. Whatever be the maximum, it would be denoted by c. So what does it imply? It implies in general all the elements of the sequence would be less than c. It may be less than 1 plus mod x, and because see the elements of the sequence which are greater than capital N, only they are having this as an upper bound. I cannot claim about these, but these are finite numbers, so I can find what is greatest among these finite numbers. Okay, what is greater among these finite number? There would be certainly some finite number, some element having some maximum value. So let me write this C as maximum of modulus of x1 comma modulus of x2 dash 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 modulus of xn minus 1 comma 1 plus modulus of x. Let whosoever be the maximum, let's say I'm writing it as C. It implies xn mod is less than C for all n belongs to natural. It implies xn is bounded. So remember, a convergence sequence is always a bounded sequence. A convergence sequence is always a bounded sequence. So I hope this is something that I had for today. I'm going to meet you tomorrow as well, and every day I'm going to meet you in this particular time only. Please keep coming. If you are right now not following things, don't worry. There would be a point there when you'll become very used to all these arguments. If you have any doubt, please let me know in the comment section. Till then, take care. Good night. Bye bye.